Hey everyone, hope you've watched my lesson 1 on calculus, which is limits. Today's going to be lesson 2, which is getting derivatives using the first principles. So differentiation by the first principles. So what actually is differentiation? Well, differentiation, that let's say I have a graph, okay? Pretty dodgy graph. It's pretty dodgy stuff. And basically means that if I have this kind of graph, I know, so let's say I have a point here, yeah? And I want to work out the gradient of the graph at that point. Normally what I'd do is I would draw a tangent and work out the gradient of that. However, we know that doing that is not always 100% accurate. So how do we do it? Well, we could use the first principles. But what are the first principles? What the first principles basically are is we want to draw a tangent that's 100% accurate. How do we do that? Well, let's say we have a line, okay? And let's say this is our point, okay? We'll call that point x, f of x, yeah? Because it's our x value, and whatever the function of our graph is, we put x into that and we get an output. So x, f of x, okay? Now, we want to work out, to normally work out the gradient of this, we need difference in y over difference in x, don't we? So here, we need to find 2 points. So let's say a point here and a point here. However, the further away that these points are going to be, because remember, the graph is curved, so it's actually going to be like a point there and a point there. The further away that these points are, the less accurate it is. So we want the limit of, so let's say that we have a distance from these points to the point that we want it. Yeah, and let's call that n. We want the limit to be n approaching 0, because we want these points to be as close as possible to where we want to work out the gradient. So let's call this point x plus n, and f of x plus n, and this point is going to be x minus n, f of x minus n, and that's all going to be on the limit of n approaching 0, okay? Because we want n to be as close as possible to that point, and we're going to work out difference. So what that's going to be f of x plus n, which is that y point, subtract f of x minus n, all over x plus n minus x plus n, because it's going to be minus x plus n, because 2 minuses make a plus. Okay, oh sorry, not 2, n. And that's the first principles. Just simplify that. It's the limit of n approaching 0 for this formula. The x's cancel out, so we're just left with 2n. And that's what the limit is for, because normally if n equals 0, you can't divide by 0, which is why it's the limit of n approaching 0, because we can't actually get to 0, but we're trying to get as close as possible. Okay? So, let's see that. Let's say that this graph, this is probably not very accurate. This is not an accurate representation of a graph. So let's say I have a graph that looks like this. Okay? It's going to be a graph that looks like that. Okay? Let's say the equation of that graph is x squared plus 1. that's going to be the function, isn't it? F of x equals x squared plus 1. So I'm going to sub that into here. So that's my first principles. So it's going to be x plus n. So I'm going to sub x plus n into here. It's going to be x plus n squared plus 1. I put big brackets around it. Subtract x minus n squared plus 1. Yeah. F of x, f minus it. I'm going to subtract them, aren't I? And that's all going to be over 2n. So let's simplify this. It's going to be equal to brackets x squared plus 2xn plus n squared plus 1 minus x squared minus 2xn plus n squared plus 1 all over 2n, which equals, if I simplify that further, x squared minus x squared, that's 0. 2xn minus minus makes plus. 2xn plus 2xn equals 4xn plus n squared minus n squared. They cancel out. And plus 1 minus 1, they cancel out. So I get 4xn over 2n. That's what I'm left with. So what does that equal? Well, it's actually the limit of n approaching 0 of 4xn over 2n. Cancel out the 2n and we get left with 2x. Now what does 2x mean? 2x is the formula that we use to work out the gradient. So what 2x means, that on this graph here, if I know what the x value is, I will be able to tell you what the gradient is. So let's say the x value is 2. Okay, let's say the x value is 2. Yeah, that means that here, if I put in 2 as x, that tells me whenever the x value is 2, so let's say here, that means the gradient there is 4. Okay, if the x value happened to be, so let's say that was 2. Okay, let's say this is 1, that means here the gradient is going to equal 2, because it's 2 times 1, 2x. Okay, now we can do that with more complex graphs. So let's say, so I'll write it out again, lim n approaching 0 of f x plus n minus fx minus n all over 2n. That's the first principles. Now let's say I want a graph that looks a bit like this. So remember, these sketches are not accurate. It's just rough. A graph that looks like that. And let's say the equation of the graph is x cubed plus 4x squared minus 9. That's just a random graph. Okay, let's do the same thing. I'm going to sub x plus n into that and subtract it when we sub x plus n into that again. So let's do it. It's going to be x plus n cubed plus 4x plus n squared minus 9, big brackets, subtract, big bracket, x minus n cubed plus 4x minus n minus 9. Okay, sorry, there needs to be a squared there, forgot about that. Looking good. So now, and that's going to be all over 2n. So now let's solve. What's that going to be? X plus n cubed. So it's going to be a bit tricky solving this, but that's going to be x squared plus 2xn plus n squared multiplied by x plus n plus 4 multiplied by x squared plus 2xn plus x plus n squared minus 9 big brackets, subtract the same thing, x squared minus 2xn plus n squared x minus n plus 4x plus 4x squared minus 2xn plus n squared. Oh, sorry, minus 9. Oh, hefty equation. All over 2n. Now let's continue here. We need to multiply that together with that. So that's going to give us x cubed plus 2x squared n plus n squared x plus x squared n plus 2xn squared plus n cubed plus 4x squared plus 8xn plus 4n squared minus 9 brackets, all subtract bracket. Oh, I told you it was a hefty equation. X cubed minus 2x squared n plus n squared x n squared minus wait, I messed up somewhere. Xn squared. Oh, for God's sake. Plus xn squared minus x squared n plus 2xn squared minus n cubed. Alright. Plus 4x squared minus 8x plus 4n squared minus 9 all over 2n. Ah, what an equation. What a beauty. So now let's simplify. Let's simplify the first bracket first and collect like terms. So there's only one x cubed, so it's going to be x cubed. 1x squared is 2x squared n. 3x squared n. That's going to be plus 3 x squared n. So it's going to be 1n squared x. It's going to be 3n squared x. So plus 3n squared x. Plus n cubed. Plus 4x squared plus 8x n plus 4n squared minus n, subtract second bracket, x cubed minus 3x squared n minus 3n squared x minus n cubed plus 4x squared minus 8x n. Sorry, I didn't add an n there, forgot about that. 8xn plus 4n squared minus 9 all over 2n. And then finally, x squared minus x squared, they cancel out. 3x squared n plus 3x squared n. That's going to give us 6x squared n. Same thing with the n squared x's. It's going to be plus 6n squared x. Plus 2n cubed the 4x cubed cancels out with a minus 4x cubed. Sorry, x squared, so they cancel out. 8xn, that gives us plus 16xn. The 4n squared, they cancel out. And the minus 9 plus 9, they cancel out. Okay, so that's all over 2n. So we can cancel 2n out and we get 3x squared plus 3nx plus n squared plus 8x, I think. Okay, good. And it's the limit of n approaching 0 for this equation. So what does that mean? Well, now finally, because the limit of x plus n approaching 0, we can just sub 0 in. So this n is going to be 0. So this number is going to be 0, and we're going to get rid of that. And the same here. So that's just going to give us 3x squared plus 8x. And that's our final formula for the gradient of this graph. Now, what does that exactly mean? Well, that means that, let's say I plug in an x value. So let's say I plug in when x is 2. If I plug 2 into that, that gives me 4 times 3 is 12 plus 16 28. That means the gradient at that point is 28. So we can do this with as many big of a power as we want, but as you can see, it gets more complex. Okay, thank you for sticking around if you have, and next lesson there's going to be a lot easier way to do this.